So one of the reasons I decided to make the videos for this quiz and not just put the answer key in Canvas was for this next problem here, which by the way is problem 3 and not problem 1. Okay, uh, so we have this graph here. You can see it's kind of like an uphill and a downhill and an uphill and a downhill kind of thing. Okay, so it says state the intervals that are increasing, decreasing, or constant. There was a lot of confusion on this problem. So you're stating intervals that are increasing, decreasing, or constant. It's fairly easy to see that the graph is going up, and then it's going down, and then it's going up, and then it's going down, right? Like that pretty much people understand. Uphill, downhill kind of thing, right? Okay, so that's not the problem. The problem is how to state the intervals. You're going along the x-axis, okay? So are there places where the curve is increasing or going uphill? Yeah, so it's going uphill from here to here, right? Okay, and that's kind of peeking out at that first little mountain. Now we're going to do our intervals from left to right, so that's why I'm starting here. And remember, there's an arrow there, so that's going off to infinity, negative infinity. Now, we read the intervals off the x-axis. It's like you're a person here walking along the x-axis. So as I'm walking here, is this curve, is it increasing? I mean, like way down here at negative infinity, is that increasing? I'm not drawing very good, but yes, it's increasing, right? Because this little arrow says it's going off that way for a long time to infinity, right? Negative infinity. So it's increasing, increasing, increasing until it gets to right there, here, this point there. Where is that on the x-axis? Well, it's about -3. So the increasing interval is all of this. So increasing, here's how we would write it. An increasing interval is from negative infinity to -3. Now, a few people, they had everything right, but they were using square brackets. These are always open intervals when you're doing increasing, decreasing, or constant. You're always going to use parentheses because at this point, at the top of the mountain there, are you increasing or decreasing? Well, you're at the top of the mountain, right? You're going to start decreasing here in just a second. So that's an increasing interval though, okay? So I have that listed. We have another place where it's increasing. It's from right here to up here, right? Like this valley here up to this mountain here. This is increasing. Now, what does it mean along the x-axis? Well, it looks like it's from about -1. I just rounded off to the nearest integer to about 2. Some of you were like 2.5, and that was fine. I didn't care. I didn't take off for that, but I just rounded to the nearest integer. So we're just looking for approximate here. Kind of hard to read those graphs. So that interval there is increasing. So, and -1 to 2 is also increasing. Okay? So those were the increasing intervals. You're walking along the x-axis and you're saying which sections is the curve increasing. Okay, so I'm hoping this makes sense. Where is it decreasing? It's decreasing right here. What interval is that? From -3 to about -1, right? Okay, so right in here, it's decreasing. So we're going to have decreasing intervals from -1 to -3. Again, we use parentheses to indicate these open intervals. And then we're also decreasing from here on down. I don't know why these colors are being all weird. Okay, so there's and this is going to go from 2 to infinity, right? 2 to infinity. And there are no constant intervals. There were no places on the curve where it was flat. That would be constant, but we don't. Okay, so that was the answer there. Or, like I said, some people were a little more accurate in their graph and said something like -0.5 or 2.5 or something like that. But whatever you decide on that, if you go to the nearest integer, that's fine. but you should be consistent probably. Notice that my intervals are matching up where those changes were taking place. Okay. Now it says to state the x and y x-intercepts and y-intercept. There are several x-intercepts. There's one here. You know what? Let me do some erasing so this is all out of our way. Okay. So there's an x-intercept here, an x-intercept here, an x-intercept here, and an x-intercept there. That's where it's crossing the x-axis, that axis that you were walking along. So x-intercepts, I put them as ordered pairs. You don't have to. You could have just said -4, -2, 1, 3. But if you're listing them as ordered pairs, which I think it's helpful, especially when you go to graph, but anyway, I know the textbooks don't always list them as ordered pairs. Notice that they're all, the y is 0 on all of those, right? Because they're right on the x-axis. -4, 0, -2, 0, 1, 0, 3, 0. Okay, those are the x-intercepts. We can only, if it's going to be a function, we can only have one y-intercept. Now, where is that y-intercept? That y-intercept is right there, right on the y-axis. So the y-intercept, again, I'm going to list it as an ordered pair. That ordered pair is 0, -3. Okay, so you can look at your answers and you can see, okay, this is what I did right or this is what I did wrong. Hopefully this helps. Except this is a long video because I have another problem to do. And this was a long problem. Okay, so again, some people didn't understand what the problem was talking about. But they want us to find g of a plus h. A plus h. So we're taking that and we're saying g of a plus h. And we're going to put that into the function. So it's a plus h squared minus 5 times a plus h. Some people still had an x in there, but we don't have an x. X is being replaced with a plus h. Now, we do want to multiply this out. You have to multiply out a plus h times a plus h. Sometimes that's the hard part. You're going to distribute that minus 5. I was going to do it on the next step, but I'll just do it now. So you have minus 5a minus 5h. Okay, but this, I have to multiply that out. You can use FOIL. You're going to get a squared plus an ah plus another ah plus h squared. So you've got, a times a times h times h times h is FOIL, the FOIL, minus 5a minus 5h. Now, you could say there's two of them, right? So you're going to get a squared plus 2ah plus h squared minus 5a minus 5h. Whew. All of this is just that part. Okay, so this part right here, I'm going to replace with a squared plus 2ah plus h squared minus 5a minus 5h. So it's really long. Now we have to subtract. So I'll do the funky pen with the subtraction sign. Subtract, and then I want g of a. Well, we know what g of a is. G of a is just going to be a squared minus 5a, right? So I'm just replacing again x. I'm replacing it with a this time. Not a plus h, but just a. So I'm going to subtract a squared minus 5a. Notice I had to put the parentheses in. Okay? All right. And then we're going to divide this whole thing by, there's just a plain h down there. So it's like three pieces. You have the g of a plus h, that's the hard part. Then you have the g of a, and that's not too bad. You're just replacing x with a. But you are subtracting, so don't forget that's a subtraction there. And then the bottom part is just h. Okay, so now we can simplify this. A squared plus 2ah plus h squared minus 5a minus 5h minus a squared plus 5a, because you got to distribute here, all over h. These problems always remind me of the things, in the movies where they're writing on the window with a little pen, That's what it reminds me of. Lots of terms. Okay, what happens to the a squareds? Those cancel out. They're one positive, one negative. What happens to the minus 5a and the positive 5a? Those cancel out. So now what do I have left? I have 2ah plus h squared minus 5h all over h. The numerator has a common factor of h, so I can factor that out. And then that h cancels with that h. Okay. So my answer is going to be 2a plus h minus 5. Okay, so that's a difference quotient, and I know it's hard, but practice. Okay.